Look up at the night sky. It's a breathtaking sight, a tapestry of twinkling lights scattered across the darkness. For most of us, this is the universe, brilliant, mysterious, and seemingly endless. You see stars, planets, maybe a galaxy or two if you're lucky or far from city lights. These are the wonders that have inspired humans for millennia, guiding explorers and sparking the curiosity of scientists and dreamers alike. For centuries we thought that was the whole universe, just what we could see with our eyes, or later, through telescopes. Our ancestors mapped the heavens, believing the visible cosmos was all there was. But what if all that visible matter is just a tiny fraction of what's really out there? What if the universe is hiding secrets, invisible to our eyes but fundamental to its very existence? Imagine the universe as a vast, dark ocean, with the stars and galaxies as mere foam on its surface. Beneath that surface in the depths lies something immense and unseen, an invisible world shaping everything we know. This is the story of dark matter, the invisible majority of the cosmos. It's a story of discovery, of peering into the unknown, and of realizing that most of the universe is hidden from view. Decades of observation, calculation, and debate forced us to this astonishing conclusion. The evidence kept piling up, challenging everything we thought we knew. When we observe galaxies, we see them spinning far too fast for their visible mass to hold them together. The stars at their edges move as if pulled by an unseen force. By all rights, these galaxies should have flung themselves apart long ago, their stars drifting off into the void. Yet they remain whole, defying the laws of physics as we once understood them. Yet they remain intact, spinning gracefully, as if held together by a cosmic glue we cannot see or touch. Something invisible with immense gravity must be holding them together. We see its fingerprints in the way light bends around galaxies, in the patterns of cosmic structure. Dark matter isn't a minor player, it's the main character in the cosmic drama. It shapes galaxies, clusters, and the very web of the universe. Ordinary matter, everything we know from planets to people, makes up just 5% of the universe. All the stars, gas, dust, and life are just a sliver of the cosmic pie. Dark matter accounts for about 27%. It's everywhere, yet we've never seen it directly. Its presence is known only through its powerful effects. The rest? An even stranger force, dark energy, makes up the remaining 68%, driving the universe to expand faster and faster. For every part we understand, there are 5 parts we don't. The universe is a puzzle, and most of its pieces are still missing. The quest to understand dark matter challenges our physics and our perception of reality. It pushes us to invent new tools, new theories, and new ways of seeing. It's not a sign of failure, but of science at its best. A relentless search for truth, driven by curiosity and wonder. Each discovery opens new questions, and every answer leads us deeper into the unknown. So let's follow the clues, step into the shadows, and hunt for the cosmic ghost. The universe is waiting, and its greatest mysteries are still out there, just beyond the reach of our eyes. The case for dark matter is built on multiple independent clues, each one a piece of a cosmic puzzle that has challenged astronomers for decades. These clues come from different corners of the universe, yet all point to the same mysterious invisible presence shaping everything we see. The first clue comes from galaxy rotation. When we observe spiral galaxies, we find something astonishing. Stars on the outskirts orbit just as quickly as those near the center. According to the laws of gravity, this shouldn't be possible if only the visible matter, stars, gas, and dust, were present. The outer stars should be flung away, or at least move much slower. It was Vera Rubin's meticulous work in the 1970s that revealed this flat rotation curve, providing the first compelling evidence for a massive invisible halo surrounding galaxies. Her observations forced the scientific community to confront the reality that most of a galaxy's mass is hidden from view. The next clue is gravitational lensing. According to Einstein's theory of general relativity, mass bends spacetime, causing light from distant objects to curve as it passes by. When we observe this bending, we can measure the total mass responsible for the effect. Time and again we find that the amount of mass needed to produce the observed lensing is far greater than what we can see with our telescopes. There's an enormous amount of invisible matter at work, distorting the fabric of space itself. The bullet cluster provides perhaps the most dramatic evidence. Here, 2 galaxy clusters have collided, and most of the mass, what we call dark matter, passed straight through, unaffected by the collision, while the visible matter, mostly hot gas, was slowed down and left behind. This separation is a cosmic fingerprint, showing that dark matter exists and behaves differently from ordinary matter. Another clue comes from the cosmic microwave background, the faint afterglow of the Big Bang. This ancient light carries subtle patterns, tiny temperature fluctuations that hold the story of the universe's earliest moments. These minute variations in temperature seeded all the cosmic structures we see today: galaxies, clusters, and the vast web connecting them. The patterns only make sense if dark matter was present, helping gravity pull matter together in the early universe. Computer simulations confirm this. Only a universe filled with cold, slow-moving dark matter can form the intricate cosmic web we observe. Without it, the universe would look nothing like it does today. Without dark matter, galaxies and clusters wouldn't exist as they do. The evidence is overwhelming, spanning from the smallest galaxies to the largest structures in the cosmos. Something massive and invisible shapes the universe on every scale, sculpting the cosmos from the shadows. We can't see it directly, but we can trace its fingerprints everywhere, from the way galaxies spin to the bending of light to the very structure of the universe itself. The universe is telling us there's more out there than meets the eye. Every observation whispers the same secret: the cosmos is built on an invisible foundation. The hunt for dark matter is a cosmic detective story, with scientists around the world searching for new clues, designing experiments, and pushing the boundaries of our understanding. The clues are clear. The culprit remains unknown. The search continues, and with every discovery we move one step closer to unveiling the true nature of the unseen universe. If dark matter is real, what could it be? Physicists have drawn up a list of exotic suspects. The leading candidate, WIMPs, weakly interacting massive particles. Heavy, invisible, and barely interacting with normal matter. WIMPs fit neatly into our theories of the early universe, a coincidence dubbed the WIMP miracle. Another contender, Axions, incredibly light particles, behaving more like a cosmic wave than individual particles. Detecting axions requires ultra-sensitive experiments, listening for the faintest signals. Other ideas include sterile neutrinos, ghostly particles that interact only through gravity. There's even fuzzy dark matter, particles so light their quantum fuzziness shapes galaxies. Each candidate paints a different picture of the hidden universe. The answer, when found, will revolutionize physics. Could dark matter just be ordinary matter that's hard to see? Astronomers once considered machos, dim stars, black holes, or rogue planets. We searched for them using microlensing, watching for brief brightening of distant stars. Some machos were found, but not nearly enough to explain the missing mass. What about clouds of gas and dust? If there were enough, we'd see their glow in infrared and radio telescopes. The universe is too transparent for this to be the answer. Neutrinos, another candidate, are too fast and light to form galaxies as we see them. Simulations with hot, dark matter produce a universe nothing like ours. The evidence points to something cold, slow, and truly invisible. Ordinary matter can't explain the mystery. We must look beyond what we know. How do you catch a particle that doesn't want to be found? The hunt for dark matter is one of science's greatest challenges. 3 main strategies: direct detection, indirect detection, and particle colliders. Direct detection: deep underground labs wait for a rare WIMP collision in ultra-pure detectors. Indirect detection telescopes search for gamma rays or neutrinos from dark matter annihilations in space. Particle colliders, smashing protons together at CERN, hoping to create dark matter and spot its absence by missing energy. Each approach is a different kind of cosmic trap. So far, the results are tantalizing but inconclusive. The search is pushing technology and imagination to their limits. We're chasing a ghost, but every experiment brings us closer. The next breakthrough could come from anywhere. What if dark matter doesn't exist? Some scientists propose MOND, modified Newtonian dynamics. MOND tweaks gravity's laws in weak fields, explaining galaxy rotation without dark matter. It works well for galaxies but struggles with clusters and phenomena like the bullet cluster. More complex alternatives, relativistic MOND, dark fluids, hidden sectors, have been proposed. None explain all the evidence as simply as dark matter. The standard model of cold dark matter fits observations from galaxies to the cosmic web. Alternative theories keep us honest, but the ghostly matter remains the best explanation. The hunt for the particle continues. The search for dark matter is a lesson in cosmic humility. It's a journey that constantly reminds us how much we have yet to discover and how small we are in the face of the universe's vastness. We once thought we understood the universe, but most of its matter is invisible to us. The cosmos is filled with mysteries that challenge our assumptions and push us to look deeper. Science thrives on anomalies. Dark matter began as an inconvenient observation. It was a puzzle that didn't fit, a clue that something fundamental was missing from our picture of reality. Instead of ignoring it, scientists embraced the mystery, building experiments and debating theories for decades. They collaborated across continents, sharing ideas and data, united by curiosity and a drive to understand. There's no guarantee of success, but the pursuit itself is the spirit of exploration. Every step forward, every failed experiment brings us closer to the truth, even if the answers remain elusive. Realizing we're made of the minority substance in the universe is humbling. Ordinary matter, the stuff we're made of, is just a small fraction of what's really out there. We are not the center nor the main ingredient, but a luminous decoration on a vast, dark structure. Our existence is a bright spark in a sea of the unknown. This doesn't diminish us, it fills us with wonder. The more we learn, the more awe we feel for the universe's complexity and beauty. We are the part of the universe that can ask questions and seek answers. Our curiosity is a bridge between the known and the unknown, driving us to explore further. The quest for dark matter reshapes our perspective on existence. It reminds us that reality is richer and more mysterious than we ever imagined. It's a reminder of how much we have yet to learn. Each discovery opens new questions, and every answer leads to deeper mysteries. The universe is stranger and grander than we ever imagined. Its secrets are waiting for us, just beyond the horizon of our understanding. And we are privileged to explore it, to be the eyes and minds through which the universe comes to know itself. We've mapped the visible universe, but at its heart lies a profound mystery. Naming dark matter and dark energy isn't the same as understanding them. This is the frontier of science, a landscape of possibility. The existence of dark matter tells us our standard model is incomplete. New particles, maybe new forces, await discovery. The answer could be a WIMP, an Axion, or something no one has imagined. We must follow the evidence, even if it leads to strange places. Science is about the pursuit of deeper questions, not just answers. The mystery of dark matter is a cosmic invitation to explore. The most exciting discoveries are still ahead. Our journey has taken us from spinning galaxies to deep underground labs. Multiple lines of evidence point to a universe dominated by invisible matter. The search for dark matter is like hearing a cosmic symphony, most of its instruments silent. Our challenge is to identify those silent players, WIMPs, Axions, or something stranger. This quest unites scientists across disciplines and continents. The answer will be a legacy for all humanity. Next time you look at the night sky, imagine the vast invisible structures that shape it. The symphony is playing and the most beautiful music is yet to be heard.